So this is Dr. B. Polaiah, working as a professor in the Department of IT, the Institution of Aeronautical, Hyderabad. So and today I'm very happy to share my one of the topic that is on definitions and technology, which we are covering based on system design technologies. So based on system design techniques, part of image processing. So I'm very to understand this system design techniques, which we are covering. The first one is define morphology. In many areas of knowledge, morphology deals with the form and structure, which we are simply called as biology, linguistics, social studies, etc. Where the mathematical morphology deals with the set of that in the field of mathematical morphology represents objects in an image. Okay, so based on this image, the object which you are considered in the image based on the biology, linguistics, social studies, etc. Okay, so but where this the mathematical morphology which we are covering based on the uses of to extract image components that are useful in the representation and description of region shape, such as boundaries extraction, skeletons, convex hull. So what is this convection hull is in terms of we are expressing Italian Inuilupo conveso. This is one of the convex hull. So this morphology filtering also we are concentrating under the mathematical morphology. So this extend in terms of thinning and pruning. So the pruning is the you are using under the mathematical morphology towards to reach your range from one end to another end. What do you mean this one end to another end? Is nothing but, for example, where we are applying your morphology, which you are want to achieve in terms of filtering and in terms of fit, so etc. So there we can apply this type of mathematical morphology. So coming to the mathematical framework used for as I said, one of the main point is pre-processing. And coming under the pre-processing, the framework will cover noise filtering, shape simplification, and enhancing object structure, skeletonization, convex hull, and coming to the segmentation, watershed, and quantitative description, area perimeter. These are the which we are applying under the pre-processing for the sake of mathematical framework, which is used for the morphology. So, set in the mathematical morphology represent objects in an image under the binary image and as well as grayscale image. The binary image which we are covering here in terms of two values which are represent in terms of zeros and ones, where the zero which cover in terms of image color is concentrating, zero is nothing but white, one is nothing but black. So once we understand that such a fundamental binary values for the sake of understanding the element of the set is coordinates x comma y of a pixel belong to the object to A to Z. So this process is considered under the set in mathematical morphology represent which objects in an binary image. Whereas if we extend this binary image disadvantage based, we can also concentrate such mathematical morphology represent in terms of grayscale image. The grayscale image is concentrated here. The element of the set is the coordinates x comma y of pixel belong to the object and the gray levels which are covered to the your even what we call 3D image point of view also. So for your binary image may concentrate 2D, but whereas grayscale not only 2D but also it extended 3D view of the grayscale process. Why? Because here you concentrate this one is 2D image because it covers only x-axis and y-axis, whereas this one is called 3D image. This is image. This is 3D image. This is 3D image. So that which we are understanding about your image, what we call the element of set in the coordinates of x comma y of pixel belong to the object and grayscale levels will be represented in z. That is z-axis nothing but third. So that covers x-axis, z-axis and y-axis. So based on this, what we call pixels representation in XYZ coordinates, which we are considered for the system design process under the system design techniques, we are using grayscale image. That is what we had to understand from this simple discussion. Coming to the this morphology we can extend in terms of system design technologies under the morphology algorithms. As we are aware about the morphological operations which we have considered from the previous slide, there are two ways. Number one, binary morphological operations. Number two, which we concentrate on the grayscale image processing also you can concentrate. But where your 5 binary morphological operations which we can be listed here, number one is erosion, that is a symbol. The symbolically process which we are apply here for the sake of operation. The operation which applied here, erosion operation, is this symbol. Whereas the second one is dilution, that is called symbolically represent one of the operation is here, which is dilution. Where the number 3 will be called as opening and number 4 will be called as a closing. What we want to concentrate here? We are concentrating such a morphological operation which we are considered under the 5 binary morphological operations symbolically represent each and every one for the sake of system design technologies achievement. So we prepare some 5 binary morphological operations which we are concentrating, being we are preparing computer science students. Algorithm point of view, we can prepare based on this each and every operation. And whereas coming to the last one, that is fifth one, is hit or miss transformation, which we are considered as a simple representation of the symbol. Okay. Now, after you understand the symbolical representation, let me take one erosion, which consider one pictorial representation of the image. Okay, dilation is one of one. So, what will be different in between these two is by the understanding the keep general shape that's smooth with respect to the object and the background. So that process which we can achieve through system design techniques which are named as erosion and dilation, those two are the morphological operations representations. So here by the combining two, understand in terms of opening and closing. Opening is concentrating only object. Closing is concentrated only background of the image. Okay. So next, coming to the, once we understand such a simple differences in between the 5 binary morphological operations, let me go in detail about what does it mean erosion. Here, that does the structuring element fit the set or erosion of a set by as A by structuring element B. All z-axis in A such that B is in A when origin of B is belongs to z-axis. That is shrinking the object by the applying one of the morphological operation which we called as opening operation, where this we are erosion operation we are applying here in between A and B. A and B are the structural elements. A is one of the set under the structural element. B is the which is subset of the A. So once 1 and 2 we are going to be belongs to here. You see here that z-axis based element B is subset of A. Subsets are equal to A. So by the operation, by the applying that operation, we may be represent here, which we call A is one of the structural element, and which we are comparing the number of pixels arranged in the matrix format, and now which is we are applying A and B here. A is the subset are equal to B. So then we how these values are varying is under the erosion operation. The erosion operation which we are comparing both here, and the remaining will be removed, only these three elements will be transformed here. Why it is possible? Because we are applying erosion method. So coming to the similarly, the erosion method in another form, instead of 1 we are concentrating, 2 we are concentrating. So we replace that and we are going to be achieve only this way, only this way. That is what we can understand. So what I mean is to understand such a erosion process based on the mathematical morphological operation we are applying is here. We are going to be see that the differences in between one structural element of A with structural element of B. We are going to be transformed from one to another is represented in the dot. You see here the dimensional of 4 is going to be concentrating in the what we call the structural element of the each and every part. So similarly, the structuring element is this is one structure element. This is one structure element. Okay, this is another structure element. This is B. This is A. Okay, so you may going to be apply here obviously erosion operation. This is operation. Your mathematical operation. Okay. Once you apply it here, then you see this the horizontal which is squared what we are applied, and the vertical which is we are applying here. You can understand that set A, B is a square structural element, and erosion operation will be applied here. Okay, and we got that ABC erosion A by B shown that shaded, and D is elevated structuring element, and C part will be A using this element. So 1 to other coordinates to achieve the your erosion operation. So coming to the such a erosion operation which we are keeping in terms of 3 by 3 structuring element of A, this A is we are keeping in terms of set of coordinates points which are varying one to other is here we are keeping in terms of 3D. Okay, so such a set of coordinates of the points is right now keeping in the view of structuring element. Yeah, structuring element is here. Structuring element. Such a structuring element which we are keeping in terms of your erosional operation. The relation of each and every pixels of we are keeping one to other in terms of neighborhood. So coming to the once we understand in detail about the system design techniques which we are applied by the help of morphological operation fitted to erosion operation process. Now we are going to use another type of operation which we call as dilation. Is an operation used to grow or thicken objects in the binary images, where the dilation of a binary image A structure element A is by a structuring element B is defined as A dilation B, and z-axis is belongs to B, and the intersection of A is equal to phi. Phi is nothing but null. does not equal to null. So that means always it contains certain information. So coming to these two, the equation is based on the obtaining the reflection of B, but its origin and translating shift its this reflection by Z. You see here, such a continuation dilation which we are applying here, A by B is the set of structuring element origin locations where they are reflected and translated. B overlaps with A at least one element. For example, use the following structuring element to delete, that is dilation with binary image as below. That is structuring element is here, and how this growing, that is what we are understanding here, how it is overlaps and growing of the your structural element. Okay, so let you see that opening and closing, as we are divided into two parts under the morphological operation. Opening process only concentration, after erosion process dilation will happen, whereas closing operation dilation, that means reverse will be happen. Dilation of process, that means after dilation process we are going to concentrate the erosion process. Let me take some of the example for understanding opening and closing under the system technologies. Here A is nothing but original, B is erosion, C is dilation, and D is opening and closing. So based on morphological operations, four basic morphological operations are used in the processing of binary images. Okay, the erosion 1 and dilation, opening, closing, which we are applying respect to figures. Let us take the A is the original image, B after applied erosion operation to the original image, we will get the erosion with this shape. And after applying your dilation operation, then we will get this. But here, that structural element of one to other we are applying in terms of only binary process. That is 0 considered as black, 0 is considered as white, and 1 is considered as a black and white. Okay. So next, coming to the opening 0, which you see 0 means nothing is visible. So 1 is nothing black color base part will be attained. So but this attain is through the opening operation, whereas closing operation is here. You see here, what is the difference between original image and after closing applied here is different. So next we are under the discussion of definition of system design technologies, which we are applying for the such a system design technologies coming under the opening and closing. What does it mean, opening and closing? So there are two important operations from mathematical morphology, which is we are used for system design technologies. They are both derived from the fundamental operation of erosion and dilation. So next, that means you can understand that opening and closing is not a separate morphological operation, but it are derived from the erosion and the dilation. Like those operations, those operators, they are normally applied to binary images, although they are also gray level operators, mathematical gray level versions. So the basic effect of opening is somewhat like erosion in the trends to remove some of the foreground, that is bright in terms of pixels, from the edges of the regions of the foreground pixels. Of course, opening and closing are we extended in terms of which we are destructive than erosion in general. So as with other morphological operators, the exact operation is determined by a structuring element. The effect of the operators is to preserve foreground regions that have a similar shape to this structuring element, or that can be completely containing structuring element while eliminating all the other regions of foreground pixels. Once we understand such a what we call the theoretical information, of course, you are so strong to understand the morphological operations by the help of, especially so far we discussed four. Number one, erosion, dilation, opening, closing. So erosion, dilation are the mathematical morphological technologies, that is operations. From there, we have derived the opening and the closing. So, for example, if you take the original image as this shape, and such a shape information we are applying towards to this part alone, then we are going to be, we want to remove that and separate it, then we apply the opening, and we want to closing it, we can apply this. So opening followed by closing is this. So what do you understand this? So that means you want to be apply the morphological process for the original image. We had to use those type of operations which we called as opening and closing. These two are based on the what we called as based on the your derived from the erosion and the dilation. So with this, actually, I want to close today our discussion for understanding such morphological operations, which we define in terms of short messages and that concepts, how it will be extended with simple examples. I'm very thankful for your kind attentions for understanding such a definition and terminology of system design techniques by the help of morphological image processing. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.